Hi, today we're going to be talking about the following example in which a company produces pipes, and on the label or advertising of these pipes, it's advertised to have a diameter of 3.25 inches. Now, in production, nothing's made exactly at 3.25 inches. If you measure it, it might be 3.2498 inches, for example. And so there's also some variation because not everything is exact. There's variation in the diameter. We're told the variation here is 0.2 inches. Here in this problem, I'm telling you the shape of the distribution is approximately normal. And this is because we would expect, so the normal distribution is plotted below. It's a bell shape. That peak, that represents the average or expected value. So we would expect the x-axis that corresponds to the peak, the highest point, to be 3.25 inches, because on average we would hope that or expect that the diameter of the pipe is 3.25 inches, the specification. Now, we would also have no reason to suspect that a pipe would be a little smaller or a little bigger, i.e. it's symmetrical around the peak. So some deviations occur below and above in about equal proportion. Okay? But most have the mean or average value. On the x-axis we have the standard deviations S listed, so one standard deviation above or below, and then 2, that 2 is not marked, and then 3 is. Okay. And the standard deviation here is denoted by sigma often. S typically also denotes standard deviation, but typically for a sample. And here we're being told that, or asked, what is the probability or proportion of parts that are discarded? A part has to be discarded if it's greater than 3.5 inches or less than 3 inches for this company. Okay, kind of loose standards. Okay, so I want to just write down for you the density function of a normal. And here it's f of x is going to be 1 over root 2 pi sigma times e to the minus 1/2 times x minus mu over sigma squared. Okay, so that's the density function of a normal distribution, and this applies for all values of x between minus infinity and infinity. And if you were to graph it, you get that graph above titled normal distribution. Okay, well, let's calculate probabilities now. And we're being asked to calculate probability a part is discarded. Well, what does it mean for the part to be discarded? Well, if x is the diameter of a random part or random pipe, then this would mean that x, well, we're told it needs to be greater than 3.5 inches. So 3.5, x needs to be bigger than that, or x needs to be less than 3 inches. If I was to look at this, so I could do the complementary event here, and I just say, hey, look, if I was to draw a normal distribution, here's 3 inches, here's 3.5. I'll just put the peak there at 3.25. I'm being asked to calculate the probability in these tails. Okay. The complementary part of this graph is not for greater than, but it'd be this middle part. So I could calculate 1 minus, and it's purely a matter of style, if you prefer to calculate the probability of the tails, or 1 minus the middle. And the middle is that x is bigger than 3 inches and less than 3.5 inches. Now, we know that mu is equal to 3.25. That's what we've been told in this problem. And we know the standard deviation. We know that the standard deviation is 0.2 inches. So you might do this. Integral from 3 to 3.5 of 1 over root 2 pi times 0.2 times e to the minus 1/2 times x minus 3.25 divided by 0.2 squared dx. And you might say, okay, I need to integrate this. I got some really, really bad news. This has no antiderivative in a closed form solution. So the bad news here is that there's no antiderivative. So you might say, okay, there's no antiderivative. How do I calculate probability? Well, we must use numerical approximation. So, numerical approximation, what's that? Well, that's things like the midpoint rule, the trapezoid rule, the Simpson's rule for calculating probability. Those are all numerical approximations. How can you do that? Well, you could do any of those methods. You could ask your calculator to do numerical approximation. You could ask your calculator to calculate probabilities with a normal distribution. You could use a calculator that's a little bit more fancy, like the one I'm about to show you, or you could use one in R or Python. So we're going to use a calculator. So we're going to calculate 1 minus the probability of the interior part, the stuff in red. And here's Google. I've Googled online stats book. online stats book, and I'm going to use one of their statistical calculators. So right here, that's what we're going to do. Okay, so let's open that. That takes us to a list of tables. We've seen the binomial distribution, but the one that we're interested in is the normal distribution. So we'll click on that. And now we can calculate probabilities with this calculator. So let's do 3.25 as the mean. The standard deviation, that's 0.2. And I want it to be, let's do between 3 and 3.5. Then we'll ask it to recalculate. And notice it shaded that middle part, so that's 0.788. Okay, so we'll go back 0.7887, or hey, look, instead of doing the 1 minus in this calculator, I could have put it's outside 3 and 3.5. Then let's hit recalculate. And notice it shaded not between 3 and 3.5, but the outside region. And it gives me 0.211. So this is 0.2113. And this is the probability a part is discarded at this company. It's not a very efficient company. So that was an example of calculations of probability with the normal distribution. Thank you very much.